Welcome back. We've question one done. We're moving on to question two. So some people would have liked question one. Some people might have gone straight to this one as the first question they did because they see the equation of the circle and say, right, I know how to do that. X squared plus y squared minus 6x plus 4y equals 12. Find the center and the radius. Two different ways of doing it. You can do the completing the square method. So you get x minus 3 to be squared plus y minus y plus 2 to be squared is equal to 12 plus 9 plus 4. You simplify down to x minus 3 to be squared plus y plus 2 to be squared equals 25. And then you can just go straight from there to say your center is 3 minus 2 and your radius is 5. Now, some people are looking at that going, what did I just do there? Because some of you will have done it a different way. You'll have looked at it as x squared plus y squared plus 2gx plus 2fy plus c equals naught. And you'd say to yourself, okay, our equation is x squared plus y squared minus 6x plus 4y minus 12 equals 0. And you'd say to yourself, okay, I can equate the coefficients. 2g is equal to minus 6. We know we're looking for a center, which is going to be minus g. So basically, you're dividing across by minus 2. So you're going to get 3. 2f is equal to 4. So minus f is going to be equal to minus 2. So your center, which is minus g minus f, minus g minus f, is going to be equal to 3 minus 2. And then your radius is equal to the square root of g squared plus f squared minus c. So it's equal to the square root of, it'll be minus 3 squared plus 2 to be squared minus c. So it's going to be minus 12 because c is minus 12. When you square all that and simplify it, you're going to get 25 underneath the square root, and that is going to give you root 25, which is 5, and that's going to be your radius. So depending on how you've learned it, you'll be looking at one way, probably thinking, God, that way is very hard. You know, so some people prefer the way on the left, some people prefer the way on the right. Andrew, which one do you prefer?
I'm way on the left, girl, me.
Yeah, I think it's probably whatever way. I think it might well be whatever way you learned it, you know, whatever way you learned it. So I prefer the way on the right, but it's either or. They both get the same answer. It's 5 marks.
Yes, as Owen just said, either of those methods are absolutely fine. Like he just said, he learned it the way on the right, I learned it the way on the left, and still use it that way. So we're looking at a 0, 3, 5 scale. So partial credit here is either the center or the radius correct, or work of merit for both. So if you had, using the left-hand method, if you had completed the square, that would count as work of merit, sorry. So that would count as work of merit. If on you were using the right-hand method, if you had written out the equation and had attempted to find g minus g or minus f, that would also count as work of merit. Okay, so that's partial credit for 3 marks, and then full credit is for having both of them correct.
Okay. So let me clear the board here for a second so we can continue on. We're given this information that P and Q are both on C, okay? And it says show that PQ is a diameter of C, okay? So there might be different ways to do it. One way you can do it is you can get the midpoint of PQ using your midpoint formula that there you can find on we have the page 18 and 19, which are your coordinate geometry formula, and you get your midpoint of PQ, which is 3 minus 2. Naturally, we can see that the midpoint of the line segment PQ is the center of the circle. Therefore, it's obviously therefore that means PQ must be a diameter. Equally, you could get the distance PQ, which is 10, and the distance is twice the radius. And because we know that P and Q are on it, because we're told that they lie on C, that must mean again that uh, the PQ is the diameter, because the length between it is twice the radius. It's a 10-mark question.
So this one's marked on a 0, 4, 8, 10 scale. So low partial credit here is work of merit. So that could be finding the length of PQ, it could be finding the midpoint of PQ, or subbing into those formulas. It could be any of those things would get you work of merit here for your 4 marks. And then for high partial credit for 8 marks, it's getting the correct answer, but no conclusion. So you do need the conclusion here because the question's asking you to show that PQ is a diameter. So you need to tell the examiner how it is that you know it's a diameter from what you're found. So you need either of the statements in red to get the full credit. If you leave out the statements but have the maths correct, then it would be high partial credit here for 8 marks.
Okay, so with A and B done, we're moving on to part C. The point R lies on the positive y-axis, and the angle PRQ is equal to 90 degrees. Find the coordinates of R. So this might be one of these cases where you're not really sure exactly what you're doing when you're starting off. But if you draw a sketch of the diagram and draw something in, it just might become clear to you what you're to do. So we're to find the coordinates of R in this case. Well, we know a couple of things, okay? If PRQ is equal to 90 degrees, that means R is on the circle because of our knowledge of geometry, knowing that the angle in a semicircle is 90 degrees. We know that R is on the y-axis, so that therefore your x coordinate must be 0 because it's sitting on the y-axis. Knowing our equation of the circle, which we had at the very start, we can sub in 0 for x. We're down to a quadratic. We solve for y. But we know the y cannot be equal to -6 because it's on the positive side. So we have an answer, and my answer is y equals 2, and then my point is 0, 2. Okay, find the coordinates of R, and that was a 10-mark question.
So this one's marked on a 0, 4, 6, 8, 10 scale. So there's low, mid, and high partial credit available here. So low partial credit is work of merit to find the answer. So that could be that you have said that because the angle is 90 degrees, then the point must lie on the circle and labeled it. Like if you, on your diagram, if you label in the point R with the 90 degrees, that counts as work of merit. Okay, because that is a correct step to get to the answer. Okay, so anything to do with that angles in a semicircle theorem, anything like that, and it can be as simple as that point marked in with the 90 degrees. Okay, that would get you work of merit. For mid partial credit, we're looking for the substitution in of the 0 and an equation in y. So if you had the line 0 squared plus y squared minus 6 times 0 plus 4y equals 12, that would be mid partial credit here. To get high partial credit, it would be a correct equation in y. So if you had the y squared plus 4y minus 12 equals 0, that would be high partial credit here for 8 marks.
Very good, very good. And Andrew, it's true kind of as a general idea, isn't it, that the students, if they're stuck on a question, that it's a good idea to try and add in as much information as they can to the diagram, because that can often get you low partial credit, even if you haven't really done much else. Am I right in saying that?
Oh, absolutely. There's numerous times I've been marking the leaving for years now, and we've been giving low partial credit for a single point plotted on a diagram.
Okay,
Okay.
gotcha.
So,
Yeah, exactly. So look, you just have to try something. You can't just, if you, as we all know, and you know yourself now from correcting it, you cannot leave it blank, because you're obviously not going to get any marks in that case.